Yeah, welcome to Easy Learning Maths 112 tutorial class YouTube. You are welcome. This class treated Maths 112, which is the course title is Algebra and Trigonometry. Algebra and Trigonometry, which is Maths 112. This Maths 112, we are going to treat, the first topic we are going to treat now is the indices. Topic, indices, lesson 1. This is our lesson 1. And let us look at this. This is the format. This is the format. And this format, this is called power. This is called power or index or exponential. You can call it exponential. And this is called base. This is called base. So this is the only thing I have to store in my memory, in my brain, this format. That this man is base, this man is base, and this man is power. As you can see, this man is a variable and this man is a variable. This man can take any number. He can take -2, he can take x, he can take 2y, he can take 1/2. That does not concern me. What concerns me is that whatever this man take to be, I know it as power or index or exponential. And whatever this man take to be, I know it as base of this power. For instance, if I have 2 raised to power 2x, right now, this man is the base, which is 2. This man have turned to be 2x, which I know it as what? Power of these 2. Another example, if I have 3 raised to power -2, in this case, this man have turned to what? Base, which is what? 3. Here, this man is -2. I can write this again. Y raised to power -4x squared. That does not concern me. What concerns me here is that I know this man as base, and I know this -4x squared as the power. Then before we can proceed on this particular topic, let us know what is called term. What do we call term? Term. What do we call term? I said what? Term. What do we call term? A term is anything that we are writing is a word term. For instance, we say A to Z is a term. An alphabet A to Z is a term. If I write A is a term. If I write X is a term. If I write Y is a term. If I write Y like this is a term. If I write XA, this is a term. If I write X plus Y, this is 2 times, a term and another term. And so if I write AX plus 2 plus Y X, this is a term. This is another term. So how many terms do I have here? 2. This and this. If I write now X plus Y, this is 2 times. X is first term, second term is what? Y. Then 0 to 9 is also a term. 0 to 9 is also what? A term. What am I saying? 0 to 9 is a what? Term. If I write 0 is a term. If I write 9 is a term. If I write 1 is a term. If I write 2 is a term. If I write 20 is a term. If I write 40 is a term. If I write 26 is a term. If I write 100 is a term. This is 1 term. This is 1 term. This is 1 term. If I write 2 plus 4, this is a term. This is a term. How many terms is here? 2. Therefore, we have known their numbers as a what? Term. This man will only be term. Remember, we said A to Z is a term and 0 to 9 is a term. And this 0 to 9 will only be a term when you stand alone. What am I saying? I said 0 to 9 will be a term when you stand alone. As I write it now, 26 is a term. But immediately is associated with an alphabet. is no more a term. He became what? Coefficients. Look at what I'm talking about. If I write down 3x, this 3 is no more now what? It's no more called what? A term. It's called coefficients. 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 And these coefficients is what tells me how many x did I add. For instance, this means what? X plus what? X plus what? X. This gives me 3x. This man is no more what? Term. It's becoming a coefficient of x. Just like when I have 4y, it simply means y plus what? Y plus what? Y plus y, which is 4y. Are you get what I'm saying? Then now, this man is no more what? A term. Because it have already associated with an alphabet, it's no more a term, it became a coefficient. So what we are trying to get here is that coefficients is what tells me how many terms did I add or I have. Just like when we say we have 2 bags of rice, 3 bags of beans. So these 2 tells us how many bags of rice and beans that we have at home. So it's no more a term. So when I say that from 0 to 9 is a term when it stands alone. But when it's attached to what? An alphabet is no more a term. Right now you have known when I'm going to say term. You have understood what I mean by term. Now let us see other things we needed to put before we proceed on this topic properly. And I say anytime we write, you have understood what I mean by term. Anytime we write is raised to power 1. If I write x like this, it simply means that this x is raised to power 1. I don't need anybody to tell me it's raised to power 1. And this same x is multiplied by 1. Is multiplied by 1. And this same x is divided by 1. And the answer is what? X. Therefore, if I write x like this, inside my brain, I know that this x is raised to power 1. And I know that this x is multiplied by 1. And I know that this x is divided by 1. And the answer is what? X. So when I write anytime I write, I know that this surround that term. For instance, if I write 2, this 2, inside my brain, I know that this 2 is raised to power 1. I know that this 2 is what? Multiplied by 1. And I know that this 2 is also divided by 1. And the answer is 2. Are you get what I'm saying now? So whenever I write any term, I know that this surrounds what? The term. If I write this word y, I know that this y is raised to power 1. And I know that this y is what? Times by 1. And I know that this y is divided by 1. And my answer is what? Y. Alright, you that is watching this video, you are raised to power 1 multiplied by 1, and that's how I see you as a human being. Anytime I can see, if I write this a term now, if I write this term, for me to see it as a term, I know that it's multiplied by 1. And I know that it's raised to power 1. And I know that it's divided by 1. And the answer is that term. If I write this now, a plus b plus 2. How many terms do I have here? A term, and another term, which is 3 terms that I have here. If I have AB is 1 term, that's multiplication, holding them is 1 term. But when I have plus, it becomes C, this is 2 terms. If I have minus 3, this is what? 3rd term. So this multiplication made a term to be 1. Multiplication made term to be 1. Understood? You get me right. Multiplication made term to be what? 1. Then let us proceed. We move to what we call law of indices. We look towards logs of indices. Logs of indices. Number 1, we have what we call multiplication law. Multiplication law. This multiplication law is telling me that a raised to power m times a raised to power what? M is equals to a raised to power n plus what? M. That's multiplication law. This multiplication law is telling me that a raised to power n times a raised to power m is equals to a raised to power n plus m. This is the format. This is what I needed to put in my brain. I don't need any other thing. This is the format for the multiplication law. And in this format, this man is constant. This plus is constant. This plus is constant. Get me right. This plus is constant. While this NMA is a variable, this N is a power, M is a power, which can take any value or whatever is going to be. It may be 2, it may be 3, it may be 4, it doesn't concern me. But what I know is that they are all variable, which will take any value. But this plus is a constant, which cannot change, Right now, let us move. And there is a condition for me to use this formula, this format. This is a formula. Then for me to use it, there is a condition. What's the condition? This and this are the same base. This base A, this base A. Then this and this are multiplying themselves. So for me to use this, for me to do this man must be of the same base and they must multiply themselves. For me to use this, for me to do this, if I have this, for me to do this and this must multiply themselves and they must be of the same base. Now let me ask you a question. The question I'm going to ask you now must answer 2 times yes before I can do this. What's the condition? Are they multiplying themselves? This and this, are they multiplying themselves? The answer is yes. This and this, are they of the same base? The answer is yes. Then the summary, add their power. So for me to do this man and this man must be multiplying themselves. And this man and this man must be of the same base. If any of these 2 conditions is not satisfied, I will not do this. If any of these conditions is not satisfied, I will not do this. Assuming that this man have the same base, but they are not multiplying themselves, I will not do this. For instance, I have 2 raised to power y times 2 raised to power x. I will now say it is equals to what? 2 raised to power y plus what? X. Y. This base 2, this base 2 multiplying themselves. So the 2 conditions is satisfied. They are the same base and they are multiplying themselves. Therefore, I will now say that y plus x, I add their power. And then, another example, if I have now 3x times 3x raised to power minus y, I will say this, the same base and multiplying themselves, I will say x, 3 raised to power x plus, which is the constant I told you that this plus is constant and this man is minus what? Y. What happened? This man have turned to minus y, but it doesn't concern this man. This man is a constant, he appeared. This man now have come out. What is going to appear? Minus y in this case. Then this is the same thing as 3 raised to power x minus y. Somebody will say, how? This leads us to what we call plus times minus. This plus times minus. You remember that we say anything we write is multiplied by 1. Therefore, this man is multiplying by 1, which is 1 is here, which is plus 1, times minus y. We give you minus y. And therefore, we say plus times minus. Let us go to this. Plus times minus. The answer is minus. Plus, this plus times minus, the answer is what? Minus. For instance, I have 2 times minus 3, the answer is minus 6. Therefore, if I have 2x times minus 3x, the answer is minus 6x squared. Are you getting what I'm saying? Then now, let us proceed. We now say that plus times minus or minus times plus. The answer is what? Minus. For instance, minus 2 times 4 will give me minus 8. That will give me minus 8. Therefore, this become minus plus times minus will give me that, and my answer is this. Let us look at another example. I have this example again. That's 3 raised to power minus 2x times 3 raised to power minus 4x. The answer will be 3 raised to power minus 2x plus, which is a constant in our formula, and that will give me minus 4x in brackets. Then what happened? And I see that this man plus times minus. What is going to give me? Well, 3 raised to the power minus 2x minus 4x. Then what does this thing mean? It means that I'm owing minus 2x. I owe somebody 2x and I owe again 4x. How many am I owing? I want to know how much am I owing. I'm owing 2x and I'm owing another person about 4x. What I'm owing in total will be what? Minus 6x. Why is this 6? This is what I owe, 2, and I owe again 4. 2 plus 4 will give me what? 6. And 6 what? X. And this minus takes me that I'm still owing 6. That takes me that total of what I'm owing is what? 6. This is total of what I'm owing. And this is what takes me that I'm owing. If this might become plus, that become what I have in my pocket. But this is what I'm going to pay out. Then this is my what? Answer. Another example. If we have that, let's say that we have 2 raised to power, 2 raised to power minus 4y times 2 raised to power 6y. This simply means that I have 2 raised to power minus 4y plus 6y, and that gives me 2 raised to power minus raised to power 2y. How did I get that? How did I get 2y? This minus 4y means what I'm owing. Plus, who is one of this plus? 6y. Who is one of this minus? 4y. 4y is owner of this minus, and 6y is owner of the plus. And this plus 6y means what I have. Minus 4y means what I'm owing. So if I'm owing 4y and I paid 6y, they will give me balance of 2y. And that balance of 2y belongs to me. That's why it's a positive. I'm owing 4y. I paid 6y. This plus 6y means what I paid. And when I pay that, they give me a balance of what? 2y back. And that's my answer. That's how I get this. Then another example. If I have this, let's say 5 raised to the power minus 6. This is 5 raised to the power 6x times 5 raised to the power minus 8x. This will give me 5 raised to the power 6x plus, which is constant in my formula, plus minus what? 8x. And this will give me, remember, plus times minus will give me 5 raised to the power 6x minus what? 8x. Remember what this plus is. I told you in our formula that this plus is what? Constant. It's always constant in our format. I said it's constant. In respect what this man is going to be is what? Constant. And in this case, this man have turned to minus 8x. And the plus still exists. Because the plus times minus give me what? Minus, which we have already explained. And this will give me the final answer, meaning that I'm owing minus 8x. This, who is one of these minus, is 8x. 8x is owner of the minus here. 8x is owner of the minus. Meaning that I'm owing 8x. I paid 6x. This is plus 6x. This is minus 8x. Meaning I'm owing 8x. I paid 6x. I'm still owing now. Are you going to say, what I paid is less than what I'm owing. I'm owing 8x and I paid 6x. I'm owing 8x, I paid 6x. I'm still owing. And how much am I still owing? It will be what? Minus what? 2x. Are you what I'm saying that? I think you understand what I'm talking about. I said I'm owing minus 8x means I'm owing 8x plus 6x means I have 6x to pay. Then when I pay 6x, I'm still owing minus. This minus told me that I'm still owing. This minus is what indicates that I'm still owing 2x. Then, this multiplication law can be extended to 3 or more times. This multiplication law can be extended to 3 or more times, more than 3 times. For instance, if I have a raised to the power n times a raised to the power m times a raised to the power k, it simply means that what a raised to the power n plus m plus k. That's what it means. And this is constant. This is constant. This is constant. This man can change. This man can change. This man can change. But these and these are constant, as we said in our first, as I said in the first one. So therefore, for instance, if I have example 2 raised to power minus 4x times 2 raised to power 3x times 2 raised to power minus 4y. I can have this to be 2 raised to power minus 4x plus 3x plus minus 4y. Then I can have this can be stated as 2 raised to power minus 4x plus 3x plus times minus will give me minus 4y. Then in this case now, we look at this. These and these are like term. What we call like term? This x, this x. This man become their coefficient. This coefficient. Please tell me how many x is here. This become the coefficients, as we say. Please tell me how many x is here. This one is y, which is a different term altogether. They are not like. Do you get what I'm saying? So this man means 4 rice, 4 bag of rice, 3 bag of what? Rice. And this one means that I'm owing 4 bag of rice. If I call this x to be rice, this one will be 3 bag of rice. I'm owing 4 bag of rice. I pay 3 bag of rice. I'm still owing. So this man will give me 2 minus x, then minus 4y. How do we get it? I'm owing 4x. I pay 3x. I'm still owing, which shows this minus. Say I'm still owing an x. Then minus 4y. I can't add this and this. Why? This is rice, this is beans. They are on like term. We can't add on like term. We can't subtract on like term. But we can what? Multiply on like term. We can't add on like term. We can what? Subtract on like term. But we can multiply on like term. So the only thing we can do on a like term is to multiply them. We can't add them. We can't what? Subtract them. Therefore, this answer will be leave this way. The only thing I can do here in this answer is to ask what is common here. What is common? Minus 1 is here. Minus 1 is here. This is minus. This is minus. They are common. I can simply write this to be what? 2 raised to the power minus. I bring the minus out. That means divide 2 by minus. If I divide this 2 by minus, I will have positive x here. If I divide 2, this man by minus, I'll have positive for y here. And this leads us to what we call division by minus. This man is common here. Minus is here, minus is here. If I divide minus x by minus, I'll have plus. What does it mean? Minus divide by minus. The answer is what? Plus. What does it mean? Minus 2 divided by minus 1, the answer is 2. This minus will kill this minus, giving me 1 divided 2 will be 2. So minus divide minus, the answer is what? Plus. The answer will give me positive. I think we're getting the notice on that. Then I have now minus 4 divided by minus 2. My answer is going to be 2. That was here. I said the minus is common. I divide 2 by minus. Means that I have x minus x divided by minus 1. Then minus 4y divided by minus 1. and what I'm going to have is positive here, and what positive what 4y. And that minus is what I bring it out. That was means the bringing minus out is common here, is here, I bring it out. What I'm going to have here is positive, what I'm going to have here is positive when I bring the minus out. So I can write this way. I can write this way. Then this law can be extended to 3 or more or 4, which you have seen. And this law can also go on in more than as many as. So the major thing we needed, what we learned in this law is this format. The format. What's the format? They must be of the same base and they must be multiplying themselves. For me to do this, they must be of the same base and they must be multiplying themselves. For me to do this, they must be of the same base and they must be multiplying themselves. If they are not of the same base and they are multiplying themselves, I will not do that. For instance now, if I have 2 raised to power x plus 2 raised to power y, I cannot do this. I can do this. This means not. If I do this, if I say this plus this, and I said is equals to this, I have committed what we call mathematical fallacy. Are you get what I'm saying now? What I have committed is mathematical fallacy, which is a taboo. I have committed a taboo. The reason is that these are the same base, but they are not multiplying themselves. So for me to do this, they must be multiplying themselves. So if I do this, I have committed a mathematical word fallacy. That's what I said. The condition for me to do this, they must be multiplying themselves and they must be of the same base. If any otherwise, this will not be done. So note it. Even in 3 times or 4 times, they must be multiplying themselves. And when you look at this, these are multiplying this are multiplying this. That means they are multiplying themselves. And as they are multiplying themselves, they are of the same base. So I add their power. And remember, in addition of their power, you know that this plus is constant. The only one that changes is this. So whatever it changed to be, this plus must be here. So these things I needed to put. This format and this format and this format. All these are built based on understanding of this format. These are things I needed to put in my brain. If I pull this, I can generate as many as of the example. So we don't go into cramming example or putting an example or cramming it. But what we needed is to know the format, which I'm explaining to you. This and this must be of the same base and they must multiply themselves before I can do this. And these can be changing. They are variable, which can be any value. But this man is constant, which must be there before I resolve, which we will see from the example we do. And this is the end of our lesson 1. Then, for you to understand this topic very, very well and be the master of it, you need to follow us in our lesson 2, and also in lesson 3 and lesson 4 to the last lesson of this particular topic before you get it right and be a master of it. So for this lesson 1, this is the foundation. The lesson 2 will give you another one. So follow us on this YouTube from lesson 1 to the last lesson of each of the topic we are treating for you to be the master of that topic. Then love this YouTube, love what you have watched now, share it and comment and subscribe. Thank you for watching this video.